Hello, today we're going to look at density curves. Now, uh, first we're going to look at the term mathematical model. Now this is just a curve that is an idealized description of a graph. For instance, we have a histogram below. This red line is a model that represents it. Notice that it doesn't represent it perfectly, but it does a pretty good job. Now that is called a density curve, where a density curve is something that is always on or above a horizontal axis, and the area is either exactly one or is exactly one underneath it. Now, keep in mind that the density curve, no set of data is exactly described by the density curve. The curve makes it so it's not going to be perfect. It's just an approximation. Now, when we have a density curve, such as this, the total area under the curve is 1. That represents the whole probability of the sample space. So the whole sample space is underneath the curve. If we have a specific thing, like between 7 and 8, the area under that is going to be the area of that event. So the probability that something is between 7 and 8 in this probability distribution is 0.12. For the folks that took calculus, you should see a good relation to integrals, and you should be really excited. You can say, hey, integrals actually are practical. Um, Now, in a density curve, if this is a symmetric distribution, the mean and the median are exactly at the same spot, right in the middle. However, if it is skewed, just like we learned in our first chapter, the mean gets pulled closer and closer to the tail, and the median lags behind. Now, the median of a density curve is what we call the equal areas point. It's the point that divides the area of the curve exactly in half. The mean of the density curve is called the balance point. This is where the curve would balance if it was made of solid material. Now, uh, in this chapter, and I guess throughout statistics, not just this chapter, we use mu as kind of like a theoretical mean. It's the mean of an entire population, where sigma is like our theoretical standard deviation. It's the standard deviation of our entire population. We'll talk more about that. Now here is a description of the balance point. Notice how if this is the mean, once it's right on the mean, the distribution is equally weighted on both sides. All right, now hopefully you can continue.